So, hello and welcome. I was expecting about 3 people to join, but it seems like putting ChatGPT in the title worked, right? Happy to see you all here. Hopefully you find, some nice insights in what I'll share today. So what we're going to do is we're going to really explore ChatGPT, the generative AI kind of trend that's been occurring over the past months, and then look a little bit at how we can leverage this in the observability space, right? So my name is Gareth Emslie. I'm a hyperscaler strategist working for Dynatrace. This is standard disclaimer. I'm not an expert in anything. I like to play with lots of different things, right? So I'm really passionate about technology, and I see obviously you all feel the same. So there's a famous quote, everything fails all the time. Does anybody know who coined that quote? Okay. So it was Werner Vogels. So he's the CTO of Amazon, right? So he famously said this where he was emphasizing the importance of basically designing systems which are resilient to failure, right? So with this in mind, it's also critical for us to obviously monitor these solutions. Modern platforms have become inherently ephemeral, right? So a lot of you use probably cloud. If you'd like to give a show of hands, how many of you deploy to cloud? Okay, so many people in the room. So you probably understand that it's really, the onus is on you as the customer to architect your solution in a resilient way, right, to avoid failures. Now, if we see this timeline, we see that across 2022, we had a number of outages, right, for AWS, a number of outages for GCP, and a number of outages for Azure. So these are outages that affected customers locally, either within region or within a data center, right? And if those customers running their workloads in those affected data centers did not architect their solutions in a resilient way, they had problems, right? And there are quite a few funny stories, actually, if you look at the RCAs. I think one set of outages was caused by a heat wave in London, right? So the cooling failed, it was too hot, and basically it took down, Oracle, Azure, and probably AWS or GCP, right? So really, some odd things can happen when running your workloads in the cloud. Another issue that we see is that the cost of downtime has escalated, right, to unprecedented levels. So for example, according to Pingdom, in the manufacturing industry, it can cost up to $250,000 for an hour of downtime. In the IT industry, it can be up to $450,000. Auto industry, $3 million. And finally, in finance or in enterprise, we have $5 million, right? So these are big numbers. We really need to understand the current situation and monitor our applications very well. So some of the challenges, I think you probably experienced some of them already, right? So today's solutions are complex, right? They're deployed across multiple clouds, potentially on-premise, public clouds, private clouds, etc. They also, in some cases, leveraging legacy observability platforms. The sheer volume of data has just exploded, right, over the years. So it's really challenging to alert on that data today. It's really challenging to understand, gain insights, right, from that data which is being ingested. In many cases, typical enterprises are very siloed, right, in nature. So it's difficult to understand, teams don't necessarily talk to each other, right? And this can cause a lot of challenges running these solutions. Another big challenge which many observability providers are have been trying to solve over the years is correlation of events, right? So we're trying to understand and raise issues to our customers to essentially understand the root cause or which failures are correlated to each other right across the stack. And this helps you and your IT teams to essentially identify and troubleshoot these problems. So, so the risk of IT outages obviously is going to grow as we go further into 2023. I'm not sure if anybody has any idea of what may be a major contributor to this. Okay, I think it's kind of a common thing that's happening at the moment, right? The macroeconomic conditions. Basically, many tech companies are laying off a lot of their workforce, right? So you have to do more with less, essentially, right? And this is where AI and an ML come in a lot of cases. So that's 1,033 tech companies have laid off over 240,000 employees, right, in 2023. So that's from layoffs.fyi. It's a big challenge. So what are customers looking for modern observability solutions? Obviously, they want to be cost effective, right? I mean, the customer doesn't want to pay a lot of money, and they want to get value, right, from their dollars that they spend. They also want a unified platform. They don't want their data to be siloed across the organization, right? Because you want to be able to understand the end-to-end situation, right? They also want their tooling to predict things, right? Predict events. This is kind of a silver bullet, right? You want to identify a problem before it happens. They also want to reduce alerting fatigue, right? I don't know if any of you have worked in operations, but you get many hundreds of thousands of alerts, which are important, right? Which do you actually look into in more detail? So your observability tool should help with that. And finally, we want to do correlation to causation, right? So we want to understand, we want to help customers to actually identify the root cause of the incidents and the issues, right? And then track it back to the exact events which occurred to minimize the downtime. Okay. So obviously, as observability vendors, we use a lot of AI already today, right? So there's a lot of predictive AI, which uses forecasting and anomaly detection, right? This is the capabilities that each and every one of you probably have in your observability platform today, right? Available to you. They also introduce causal AI, which is essentially AI which is able to understand, the relationship between entities and the metadata which is collected, and able to actually identify, traverse the tree and identify which component caused an outage, right? This takes also as an input domain context, and also we do anomaly detection, obviously. So, what's been happening in the world of machine learning? So obviously we've had a significant amount of innovation in the large language model space, and this was triggered by Google, I think, in 2017, where they released a paper, I think it was around transformers. They introduced transformers. And this basically is what has driven many of the innovations until today. Some of these innovations have basically occurred in these areas, right? So things that these large language models are really good at are things like text summarization, right? And generating new text. Code generation. Image generation as well, if you looked at DALL-E 2 and 3. Also, conversational UI, right? So chatbots, virtual assistants, and all those types of things. Sentiment analysis is another area which is really good at. So these are areas where a lot of software vendors are looking at their products today and seeing how they can integrate large language models, right, to improve their products, leveraging a lot of these different types of integrations. But what is a large language model? So, large language models essentially use neural networks, right? Some of you may remember, maybe your university days, you may have done some neural nets. It's essentially trying to model the biology of the brain, and they're designed to recognize patterns, right? And they do this through mathematical formula, and they basically are very good at it, right? So here we can see multiple layer neural net, and we can see one of the nodes expanded on the right-hand side, right? So it's essentially a stacked neural net, and basically it's composed of several layers, right? So you input a photo of a dog, the photo is converted into vectors and essentially numbers, and then it runs through the neural net, and it tells you it's a dog, right? So how have large language models got so good? Well, one of the factors is that they've been trained essentially from data from the entire internet, let's say, right? So they use a huge amount of data, right, to train these models. So the data quality is key, really, right, to getting a good quality model. So obviously you need to select which data you want to leverage, right? So there are a lot of data sources like Kaggle and Google Dataset Search, etc. You need to apply some quality filters, right? So you might have to normalize the text, converting it to lowercase. You could remove stop words, etc. You also need to remove any duplicates, right, which may skew the model, right? Another thing that must be done is removing PII, right? So any personally identifiable information should be removed. And the final step is tokenization, right, where you convert essentially words to tokens or text to tokens, and those tokens are then used by the model, right? Okay. So one of the things you need to do when you're training one of these models, these general purpose models, is basically tuning for performance, right? And the way this is done is via what's called parameters, and these are essentially composed of weights and biases, right? So initially these weights and biases are set to random values, but as you train the model, basically these numbers are updated, right? Okay. Another area of improvement is basically the introduction of reinforcement learning with human feedback. So here, what you do is you take a pre-trained model like GPT-3, right? A human actually demonstrates what a good prompt and completion looks like. This produces a fine-tuned model, so this is kind of high level, right? Produces a fine-tuned model, so for example, GPT 3.5. So using this new fine-tuned model, the human then generates prompt and completion pairs and then ranks those, right, to produce a reward model. So, and then this reward model is what is combined with the original base model, so the GPT-3 base model in this scenario, to produce a reinforcement learning policy, right? So this is what the entire process looks like, really at a high level for reinforcement learning. And this is used to essentially improve the quality, right? of your completions of the model. Okay. So historically, basic language models are trained really to predict the next word. Right? So some examples are this next token prediction. So this is a model which, given a sequence of words, it actually predicts the next word. Right? So it's fairly simple. Another one is masked language modeling. So the model is given a sentence with a missing word, and it needs to fill in the word. Right? The problem with these was that there are limitations. Right? So it's unable to fully understand the context, and the inputs are processed sequentially on an individual basis. Right? So it can be slow. With ChatGPT, it was built on top of the latest breakthroughs, right, in language model design at the time. So what they did is they introduced this concept of a generative pre-trained transformer, right? We heard about transformers in the Google, in that white paper released by Google in 2017. But in 2018, GPT models were basically launched by OpenAI, right? These were autoregressive large language models, right? So if you look on the right-hand side, you'll see an example of a diagram from DeepMind's WaveNet. Yeah. Where it's predicting, based on inputs, it's predicting the next output, right? So the other thing which I forgot to talk about was the autoregressive large language model is just basically a large language model which is able to predict the next word, right? One token at a time, actually, sorry, not word. Okay. So ChatGPT, some facts about ChatGPT. So it's a version of 3.5, GPT 3.5. It's fine-tuned on dialogue. With over 175 billion parameters, which is quite a lot of parameters, right? It interacts in a conversational way, right? So it's very comfortable for us to talk to. And it's able to answer follow-up questions. It's able to, admit its mistakes and challenge incorrect premises, etc. Right? So it's really a breakthrough, right, in this space. Some of the use cases for observability are obviously conversational UX, right? So this is where you use natural language essentially to control or talk to, let's say, a software solution or a platform. So you're able to query data, for example. It's also obviously very good at code generation. So something that we are able to do is, for example, generate SQL. So you can ask it to generate you some SQL to query some data in a specific table, for example. Another area which is really interesting is intelligent problem remediation. So given the right context, we could leverage these large language models to actually help us to resolve outages faster, right? And also enriching, for example, problems which I identified, enriching that with additional context. This is something which LLMs would be very good at. So, I'm not sure if any of you have played with ChatGPT, but as you can see on the screen, there's an example, right? So I just asked ChatGPT based on a problem which was identified, what could be the root cause, right? For, I think it was garbage collection suspension time in Java. So it came up with, and I asked it twice, right, the same question without changing anything, right? The problem is that it's very much non-deterministic, right? It gives you a different answer every time, right? But we expect computers to give us the same answer with the same inputs. right? So there's a bit of a challenge there in how we leverage this type of technology in something like an observability platform, because the users need to expect, the same behavior every time, right? Or expecting the same behavior. It also takes a lot of questions and answers to build up context around a particular problem, right? So here I'm asking it, why a backend service was experiencing additional latency. It asks you, okay, have you checked this? Have you checked that? And so eventually you'll get to the answer, right? But it's a long process. And maybe if you're firefighting or you have a problem which is critical, you don't have time, to have this long discussion with an AI. So, it's taking over the world, right? Our jobs are all going down the toilet. I don't know, how are we going to feed our children? No, that's not the case, right? So ChatGPT and GPT in general has its nuances, its issues, right? It's not perfect. It is prone to nonsensical responses, right? It's sensitive to minor changes in prompting. It's excessively verbose, right? It gives you so much information, and it makes up things, right? So it hallucinates. It doesn't necessarily base everything on facts. So given these imperfections, a new discipline is emerging or has emerged, right? And you probably see it every day online, right? It's called prompt engineering. And your job is just to engineer prompts, right? To get these models to solve a specific task or to give you a specific result, right? And it's like magic at the end of the day. It's a lot like, I suppose, like SEO. So one of the primary objectives here is really you want to build an optimal prompt, right, for your given scenario. Every time you're given the same input, you want more or less, the same output. So how can you do that? Obviously, you do this in various ways, right? So obviously, you have to set some context for the model using different types of roles. So we have system role, assistant role, and user role. So the system role, we'll look, I think, in the subsequent slide around how you can prime a model, but you can use it to give it some instructions right before you start asking it questions. Okay. So as I mentioned, you can use system prompts or system messages to set behaviors, right, at the very simplest level. So here I'm telling, ChatGPT, you're an AI assistant. You need to help us to solve essentially IT operations issues, given some JSON data, right, from our observability platform. Okay. You can also tell it things like what format you expect the response to come back in, right? So you could ask it to generate CSV or JSON or whatever you like, right? In this case, I just wanted a title and a description, right, of the security problem. So now, once I actually prompt this primed model, you can see I provided some JSON, which is just some JSON from the observability tool about a vulnerability. And the assistant will respond and give me, okay, it's understood, okay, the title is, regular expression denial of service. It's understood, how to describe the issue. So it's come up with a fairly decent description, right, of the issue. Now, we could have made use of some functions, right, which I won't go into, but for converting certain things like the timestamps, which are in, I don't know if they're in epoch or whatever, right, or in milliseconds. But it also, tells you to go, it provides the deep link, to the Dynatrace platform, where you can find more information about the security problem. So actually, it does quite a good job at describing things, right, and generating text. One of the strategies for trying to improve the quality of completions is, well, there are many, but one of them is zero-shot, one-shot, and few-shot learning. Right? I'm not sure if you played around with it, but basically, so here we can see an example of one-shot where you say, okay, here's a description, give me a category, and you'll see here with a different description, so these are from CVEs, from the vulnerability database. The assistant is categorizing correctly these CVEs, right? So one was denial of service. It's just making up the category, right, itself. And the other is cross-site scripting. So here we look at few-shot learning, where we actually provide a couple of examples, right, of what we're looking for. And we can see that the categories that we're using shorthand, so acronyms for those categories. And you'll see in the last case where we haven't actually supplied the category and we want the model to actually populate the category, we can see that it's categorized as XSS instead of cross-site scripting. So this is based on the fact that we provided initial examples, right, of what we want. So in this case, the model is not, retrained or anything, right? It's just you're priming the model, right? So you're providing some context before you actually start to ask questions. Okay. Some rules of thumb. So leave as little to interpretation as possible. Right, you need to really restrict the operational space. So be specific, in other words. You need to be descriptive, right? So use analogies, really try to be verbose in describing what you want. So you also may need to repeat yourself multiple times, right? Like I said, it's not necessarily a science, it's more like an art or a form of magic, right? You just need to try things out, and maybe repeating something helps. Order can also make a big difference in the quality of the completions that you get, right? So make sure that you try out different orders of questions. Also, breaking things up into smaller tasks can help. It's also very important, basically, to tell the model that, it can say that it doesn't know, right? Otherwise, it just tends to make things up, right? So, and that's kind of a little bit annoying. So, what can we do with this in a realistic solution, right, where we actually have a problem to solve, right, in observability space? So we have an IT ops engineer or a security engineer who has an issue which has been raised in their tool, right? It's a security issue with the ID S-4073. And we have built, in our case, let's say, we have built a software agent, right, which this ops engineer is able to interact with. The software agent can query problem data from the observability tool of choice, right? So that might return JSON, or you might define functions within ChatGPT, for example, to do this. So it'll go out and look for, some context around this vulnerability which has been identified, right, in the environment. This is returned to the agent. The agent will then call into embedding model, which will produce vectors which are just like numbers, essentially. This vector data is then used to search a vector database and try to find items or knowledge which has already been learned, right, based on the new vector data. Finally, once all these steps have been completed, right, the software agent generates a prompt, which is then sent to the base model, which would be, in this case, ChatGPT, which is used then to formulate the response, right, given all the data which has been collected up to that point, right? So many companies are investing quite heavily, right, in generative AI, and that may be in infrastructure side, hardware, software. In particular, Amazon, Azure, and Google Cloud have all made large investments, right? So Azure made $10 billion investment into OpenAI really early on, right? And they have now a service called Azure OpenAI, leveraging this tech. They also adopted the ChatGPT open standard, right? So this is very nice. So we have a plugin standard right across the ecosystem, which they can develop plugins which target both platforms. And they have a number of nice tooling around, prompt development, prompt engineering, which they have announced, which is really great, right? And the same is happening in AWS and GCP, right? So AWS have got a bunch of hardware that they've announced. They also have Bedrock and things like Amazon Titan models, which can be leveraged, right, in their cloud. So obviously, Dynatrace as well is investing in the space, right? I'm not sure if you've seen many observability vendors have their version of a Copilot. You may have seen it also in the Microsoft ecosystem or GitHub, right? They have developed Copilots, which essentially help you do your job, right? Your daily job, whatever that may be. It might be in security, for example, or development to help you develop your software. In the case of Dynatrace, really we're looking to combine that more traditional AI, which we've always had, so the predictive AI and the causal AI, together with the generative AI piece, which is very good at generating content and code and things, right, to help our users to do their job, right, faster, better, and with less issues. So the things like, I don't know, setting up dashboards potentially, or what else? Converting natural language into our SQL-like language for querying data, right? Those types of things can be done through the Copilot. Okay. So do you think large language models are the panacea? Do you think they're going to solve the world's problems? No? Yes? No? Okay. Yeah, you're right. I mean, so obviously we saw there were a number of challenges, right, leveraging these models. It's really important kind of how you engineer your prompts. You really need to understand and leverage the correct tooling, right? Things like LangChain, semantic kernel. There are a number of projects out there which help you, better utilize these models. And I encourage you to take a look at those projects. Also, protecting intellectual property and data privacy is very important, right? Because theoretically, I think OpenAI at least, they use your prompts that you submit to further train the model, I think. Companies like Microsoft have introduced ways which allow you to fine-tune the model based on your own data, right? And not having to share that back to public domain. It's also important to understand the risks, right? So there's a lot of security concerns around prompt engineering and large language models in general. Right? I think you can do things like prompt injection, where you can kind of break out of a sandbox, let's say, which you've set up yourself with your system prompts, etc., to do other things that you're not supposed to be able to do. Right? So how much do you think it costs to train one of these large language models? Can anybody hazard a guess?
Depends on the time. 6 million.
6 million. Can be more. I think it cost 20 million in some cases, right? Not all cases. So we're talking, one of the numbers that I saw was 20 million in energy costs, right? This is a huge amount of money. And a huge amount of energy, right? I mean, for the planet and whatnot. So yeah, I think we have to be very careful how we use these things, and we have to be very cognizant, of when to use it, and obviously share as much as possible, right? So, it doesn't make sense for everybody to train their own models, right? We need to try and reuse, these generic models for our own use cases without spending millions, to train new models for some unique scenario. Okay, so that's all I have. I mean, if you have any questions, just let me know. I can answer them now, or you can reach out to me any time. Thanks a lot.